Chronic inflammation is connected to 7 of the 10 leading causes of death in the United States. Heart disease, cancer, stroke, diabetes, Alzheimer's, kidney disease, and chronic liver disease all share a common underlying mechanism: sustained, low-grade activation of the immune system that quietly damages tissues, blood vessels, and organs over years and decades. You don't feel it happening. There's no fever, no swelling, no obvious signal that something is wrong. Your body is running an immune response that never shuts off, and over time, it breaks down the systems it was designed to protect. 6 in 10 American adults currently live with at least one chronic disease. The Centers for Disease Control identifies chronic inflammation as a significant contributing factor across nearly all of them. The good news is that specific foods at your grocery store contain compounds that measurably reduce inflammatory markers in clinical trials, not vague superfoods with unsubstantiated health halos. Compounds with named biochemical mechanisms. Omega-3 fatty acids that suppress the same pathways as prescription anti-inflammatories. Polyphenols that cross the blood-brain barrier to protect neurons. A compound in olive oil that inhibits the same enzymes as ibuprofen through an identical pharmacological mechanism. These aren't wellness trends or influencer claims. They're peer-reviewed biochemistry, published in the same journals that pharmaceutical companies use to develop drugs. We're counting down the 15 most powerful anti-inflammatory foods you can buy at any grocery store, with the specific clinical evidence behind each one. But stay through the entire list, because at the end, we're revealing 3 foods that millions of people eat specifically because they think they're fighting inflammation, that are actually fueling it. One of them is probably in your refrigerator right now. Number 15. Tart cherries. The compound that makes tart cherries red, a class of pigments called anthocyanins, inhibits COX-1 and COX-2 enzymes. Those are the same enzymes that ibuprofen and aspirin target to reduce pain and swelling. Clinical studies on gout patients showed tart cherry consumption reduced uric acid levels and decreased the frequency of flare-ups. Exercise recovery research found reduced muscle soreness and lower inflammatory markers in athletes consuming tart cherry juice after intense training. The difference between tart cherries and ibuprofen is that ibuprofen damages your gut lining with prolonged use. Tart cherries don't. Look for tart cherry juice concentrate, unsweetened or frozen tart cherries. Sweet cherries have significantly fewer anthocyanins and don't produce the same clinical effects. Number 14. Lentils and legumes. The mechanism here is indirect but powerful, and it operates through a system that most anti-inflammatory food lists ignore entirely: your gut microbiome. Soluble fiber and resistant starch in lentils, chickpeas, and black beans feed beneficial gut bacteria, specifically Bifidobacterium and Lactobacillus species that colonize the lower intestine. Those bacteria produce short-chain fatty acids, SCFAs, as a metabolic byproduct of fermenting the fiber you fed them. The 3 primary SCFAs, butyrate, propionate, and acetate, strengthen the gut lining, reduce intestinal permeability, and suppress systemic inflammation through the gut immune axis. Roughly 70% of your immune system resides in and around the gut. When the gut lining is intact and the bacterial balance favors beneficial species, immune activation stays localized and appropriate. When the lining breaks down and pathogenic bacteria dominate, inflammatory signals leak into the bloodstream and become systemic. Higher legume intake is consistently associated with lower CRP in large population studies across multiple countries and dietary cultures. Your gut bacteria eat what you eat. Feed them fiber, and they produce anti-inflammatory compounds. Feed them sugar, and they produce inflammatory ones. That trade happens at every meal. Canned lentils are nutritionally equivalent to dried, require no soaking, and cost under $2. Number 13. Green tea. The key compound is EGCG, epigallocatine gallate. EGCG inhibits NF-κB, the master transcription factor that switches on inflammatory genes inside every cell in your body. NF-κB is the name you need to remember from this video, because it appears again and again across the most powerful anti-inflammatory foods. When NF-κB is activated, Your cells produce inflammatory cytokines, the chemical messengers that drive chronic inflammation. When NF-κB is suppressed, the inflammatory cascade slows. Meta-analyses of clinical trials show regular green tea consumption reduces CRP and IL-6, two of the primary biomarkers of systemic inflammation. Steep green tea at 175 degrees Fahrenheit for 3 minutes. Boiling water destroys the catechins. Matcha delivers higher concentrations because you consume the entire leaf rather than steeping and discarding it. Number 12. Cooked tomatoes. The key compound is lycopene, the carotenoid that gives tomatoes their red color. Lycopene neutralizes reactive oxygen species that trigger inflammatory cascades in blood vessels and tissues. The critical detail is bioavailability. Raw tomatoes deliver lycopene, but your body absorbs very little of it in that form. Cooking tomatoes in the presence of fat increases lycopene bioavailability by 2 to 8 times. Canned crushed tomatoes or tomato paste cooked in extra virgin olive oil is the optimal delivery format for lycopene absorption. Raw tomatoes give you lycopene. Cooked tomatoes in olive oil give you 2 to 8 times more. The cooking does the work your digestive system can't. Number 11. Avocado. Oleic acid, the same monounsaturated fatty acid found in olive oil, plus fat-soluble carotenoids including lutein and zeaxanthin. A randomized controlled trial published in the Journal of the American Heart Association found that 1 avocado per day reduced oxidized LDL and small dense LDL particles. Oxidized LDL is the specific form of cholesterol that triggers inflammatory responses in arterial walls and drives the plaque buildup that leads to atherosclerosis. Standard LDL is not the problem. Oxidized LDL is. That distinction matters because reducing total LDL without addressing oxidation misses the inflammatory mechanism entirely. The carotenoids in avocado, lutein and zeaxanthin, are fat-soluble, meaning they require dietary fat to be absorbed through the intestinal wall. The avocado provides both the anti-inflammatory compound and the fat needed to absorb it in the same food, which is why avocado's bioavailability profile outperforms supplements that deliver the same compounds without the fat matrix. The small dark Hass variety has higher fat content and more polyphenols than the larger smooth-skinned Florida varieties you sometimes see at the grocery store. Number 10. Dark chocolate at 70% cocoa or above. The active compounds are flavanols, specifically epicatechin and catechin. Flavanols improve endothelial function, meaning they make your blood vessels more flexible and responsive. A meta-analysis of 14 studies found that dark chocolate consumption significantly reduced CRP compared to control groups. The threshold is 70% cocoa. Below that, the sugar content negates the anti-inflammatory benefit. Below 70%, you're eating a candy bar with a health label. Above 70%, you're eating a food that measurably reduces CRP. 1 to 2 ounces per day is the dose used in clinical trials. Number 9. Ginger. The active compounds are gingerols and shogals. Gingerols inhibit prostaglandin synthesis, the same biochemical pathway that NSAIDs like ibuprofen and naproxen target to reduce pain and inflammation. Randomized controlled trials in patients with osteoarthritis found that ginger extract reduced pain scores at rates comparable to ibuprofen, with fewer gastrointestinal side effects. Ginger targets the same prostaglandin pathway as ibuprofen. The clinical trials in arthritis patients found comparable pain reduction with fewer side effects. Fresh ginger root, grated or sliced into food or tea, retains the highest gingerol content. Dried ginger powder also works. Number 8. Broccoli and cruciferous vegetables. The compound that matters is sulforaphane, which is released when you chop or chew raw cruciferous vegetables like broccoli, Brussels sprouts, and cauliflower. Sulforaphane activates the NRF2 pathway, the body's master antioxidant defense system. When NRF2 is activated, your cells increase production of glutathione, the most powerful internal antioxidant the human body produces. Sulforaphane has been the subject of over 3,000 peer-reviewed papers. Here's the detail that changes how you cook. Chop your broccoli and let it sit on the cutting board for 40 minutes before applying heat. That waiting period allows the enzyme myrosinase to convert the precursor compound glucoraphanin into sulforaphane. If you cook immediately after chopping, the heat destroys the enzyme before the conversion is complete. You lose most of the sulforaphane. 40 minutes of patience on the cutting board changes the biochemistry of the vegetable on your plate. Number 7. Sardines and mackerel. The same EPA and DHA omega-3 fatty acids found in salmon, but at a fraction of the cost, with significantly lower mercury, and with a sustainability profile that makes them one of the most responsible protein choices available. Small, short-lived fish sit near the bottom of the marine food chain, which means they accumulate far less mercury, PCBs, and other persistent pollutants than large predatory fish like tuna, swordfish, and king mackerel. A can of sardines contains roughly the same mercury as a glass of tap water. A serving of tuna can contain 50 to 100 times more. EPA and DHA from sardines and mackerel are converted by your body into resolvins and protectins, the same specialized pro-resolving mediators that make salmon the #1 food on this list. Sardines actually deliver more omega-3 per serving than most salmon species. The difference is perception. Salmon feels like a premium dinner. Sardines feel like a survival food. The biochemistry doesn't care about the perception. A can of sardines in olive oil costs under $3 and provides a full daily dose of the omega-3 fatty acids that suppress IL-6 and NF-κB activation. Check the ingredient list on the can. It should say sardines, olive oil, salt. 3 ingredients. If the oil listed is soybean or sunflower, choose a different can. Those oils are high in omega-6 fatty acids, which compete with omega-3 for the same enzymatic pathways in your body. Sardines and soybean oil partially negate the anti-inflammatory benefit of the fish itself. Number 6. Turmeric with black pepper. The active compound is curcumin, the yellow pigment in turmeric root. Curcumin inhibits NF-κB, the master inflammation switch we first introduced with green tea. It also suppresses COX-2 and multiple inflammatory cytokines. But here's the critical detail that most health content leaves out. Curcumin on its own has extremely poor bioavailability. Your body absorbs almost none of it. Piperine, the compound responsible for the bite of black pepper, increases curcumin absorption by approximately 2,000%. 2,000. That's not a rounding error. That's the difference between a medicine and a yellow stain on your cutting board. Always combine turmeric with black pepper and a fat source like olive oil or coconut oil. Without pepper, most of the curcumin passes through your digestive system unabsorbed. Every food so far has clinical evidence behind a specific compound. The next 5 are the ones with the strongest research, the most measurable effects on inflammatory biomarkers, and the most practical impact on your daily health. Number 5. Walnuts. The key compounds are ALA, a plant-based omega-3 fatty acid, and illegitinins, a class of polyphenols concentrated in the papery brown skin of the walnut that most people consider bitter or unpleasant. ALA is partially converted by your body into EPA, the same anti-inflammatory omega-3 found in fish. The conversion rate is low, roughly 5 to 10%, which is why walnuts don't replace salmon. But illegitinins add a second mechanism that no other common nut provides. Your gut bacteria metabolize illegitinins into urolithins, compounds that clinical trials have linked to improved mitochondrial function and measurable anti-aging effects at the cellular level. Urolithin A, the primary metabolite, has been shown in human trials to enhance muscle function in older adults by improving mitochondrial efficiency. Mitochondrial dysfunction is both a cause and consequence of chronic inflammation, making urolithins uniquely relevant for anyone dealing with inflammation-related fatigue or age-related decline. A Predamid sub-study found that participants consuming 3 or more servings of walnuts per week had significantly lower inflammatory markers than those consuming none. Buy raw unsalted walnuts. Roasting at high temperatures oxidizes the polyunsaturated fats and degrades the polyphenol content in the skin. The bitter, slightly astringent taste of that papery skin is the illegitinins expressing themselves. If you peel it off, you lose the compound that makes walnuts uniquely valuable. Number 4. Spinach and leafy greens. 1 cup of raw spinach provides approximately 145 micrograms of vitamin K, which exceeds the daily adequate intake for adults. Vitamin K regulates inflammatory responses by inhibiting NF-κB, the same master switch that green tea and turmeric target. Higher leafy green intake is one of the most consistent dietary predictors of lower CRP across large population studies worldwide. Spinach also provides lutein, folate, and dietary nitrates that support cardiovascular function. Both raw and cooked preparations deliver benefits through different pathways. Cooking increases the bioavailability of lutein and beta-carotene. Raw preserves vitamin C and folate. The most effective approach is to eat leafy greens in both forms across the week. 1 cup of raw spinach exceeds your entire daily requirement for the vitamin that helps keep the master inflammation switch in the off position. Number 3. Blueberries. The key compounds are anthocyanins, the pigments that give blueberries their deep blue-purple color, and pterostilbene, a polyphenol structurally similar to resveratrol but with 4 times better bioavailability, meaning your body absorbs significantly more of it from food. Anthocyanins do something that almost no other dietary antioxidant can do. They cross the blood-brain barrier, the tightly sealed membrane that protects the brain from most circulating compounds in the bloodstream. This crossing ability is why blueberries are uniquely linked to cognitive protection in aging populations, not just general systemic inflammation reduction. The brain is an immunologically privileged site, meaning most anti-inflammatory compounds you consume never reach it. Anthocyanins do. A USDA Human Nutrition Research Center study showed that regular blueberry consumption improved memory scores and reduced inflammatory markers in older adults over a 12-week intervention period. Separate randomized controlled trials demonstrated measurable CRP reduction with consistent daily intake. The research specifically used amounts equivalent to 1 cup of fresh blueberries per day, a dose that's practical and affordable. Frozen blueberries retain anthocyanin content equal to or better than fresh because the freezing process ruptures cell walls, increasing compound release during digestion. This means frozen blueberries are not the inferior option. They are the biochemically superior option for anthocyanin delivery. Wild blueberries have approximately twice the anthocyanin concentration of cultivated highbush varieties because the smaller berry size means more skin surface area relative to volume, and the anthocyanins are concentrated in the skin. If your grocery store carries frozen wild blueberries, they are the best buy in the entire produce and frozen section for anti-inflammatory value per dollar. Number 2. Extra virgin olive oil. The compound that matters most is oleocanthal, the polyphenol responsible for that peppery catch you feel in the back of your throat when you taste fresh, high-quality EVO-O. Oleocanthal inhibits COX-1 and COX-2 enzymes through a mechanism that is pharmacologically identical to ibuprofen, not similar to ibuprofen, identical in mechanism. The difference is that ibuprofen was synthesized in a laboratory and oleocanthal was synthesized by an olive tree. Researchers at the Monell Chemical Senses Center estimated that 50 milliliters of extra virgin olive oil provides roughly 10% of the anti-inflammatory dose of ibuprofen used for adult pain relief. That means consistent daily consumption of EVO-O delivers a low-level, sustained COX-inhibiting effect without the gastrointestinal erosion that chronic NSAID use produces. The Predimed trial, one of the largest dietary intervention studies ever conducted with approximately 7,400 participants across Spain, found that a Mediterranean diet supplemented with EVO-O reduced major cardiovascular events by roughly 30%. That single study shifted clinical dietary guidelines worldwide. Hydroxytyrosol and oleuropein, 2 additional polyphenols in high-quality EVO-O, suppress NF-κB signaling and reduce oxidative stress markers independently of oleocanthal, meaning olive oil fights inflammation through at least 3 simultaneous biochemical pathways. That peppery burn in your throat when you taste EVO is oleocanthal expressing itself. If the oil tastes smooth, mild, and completely inoffensive, the polyphenols are gone, and the anti-inflammatory compounds with them. Dark glass bottle, harvest date on the label, single origin, peppery flavor. Those are the 4 markers that separate a functional anti-inflammatory food from a bottle of degraded fat with an Italian name. Number 1. Wild salmon. The single most studied anti-inflammatory food by research volume, a 4-ounce serving delivers 1.5 to 2.2 grams of EPA and DHA, the long-chain omega-3 fatty acids that directly suppress IL-6, TNF-alpha, and NF-κB activation. But EPA and DHA don't just suppress inflammation. Your body converts them into resolvins and protectins, specialized pro-resolving mediators that actively shut down inflammatory processes that are already underway. This distinction matters. Suppression slows inflammation down, resolution ends it. No other class of dietary compound performs this function. Resolvins are not found in supplements. They are not available in capsule form. They are produced by your own body from the EPA and DHA you consume in fatty fish, and they perform a biological task that no other food compound replicates. The American Heart Association's 2025 dietary guidelines specifically recommend 2 3-ounce cooked servings of fatty fish per week to achieve clinically significant reductions in cardiovascular inflammation. That's a concrete, measurable target based on the clinical evidence, not a vague suggestion to eat more fish. Wild-caught sockeye and coho have higher omega-3 content and lower contaminant levels than most farmed Atlantic salmon. The color difference tells you something. Wild sockeye is deep red because the fish feed on astaxanthin-rich krill in open water. Farmed salmon is often naturally gray and dyed pink with synthetic astaxanthin added to the feed. Canned wild salmon is nutritionally equivalent to fresh and costs a fraction of the price. The can often contains wild Alaskan sockeye that would cost 3 to 4 times as much in the fresh fish case at the counter. Wild salmon doesn't just suppress inflammation. Its omega-3s are converted into compounds that actively resolve inflammatory processes your body is already running. Not a pause button, a shutdown switch. That's why it sits at number 1. Those are the 15. And now for the 3 that will change how you look at what's already in your fridge. 3 foods that millions of people eat specifically because they believe they're fighting inflammation. The research says they're fueling it. Dangerous number 3. Store-bought acai bowls and smoothie bowls. The acai berry itself is legitimately anti-inflammatory. It contains anthocyanins, the same class of compounds that make blueberries one of the most powerful foods on this list. But the bowl your smoothie shop or grocery store builds around the acai is a different product entirely. A typical store-bought or chain restaurant acai bowl contains 50 to 80 grams of sugar per serving. The World Health Organization recommends no more than 25 grams of added sugar per day for women and 36 for men. One bowl exceeds the entire daily limit before you've eaten anything else. Break the bowl down into its components. The granola clusters on top are bound together with sunflower oil or canola oil. Without those oils, the clusters would be loose oats, which wouldn't look as appealing or hold their shape in the bowl. The nut butter drizzle is cut with hydrogenated oils or seed oils to reduce cost and improve pourability. The honey or agave drizzled on top adds another 10 to 15 grams of simple sugar on top of the sugar already present in the fruit juice base that constitutes most of the acai blend. Some shops add banana, mango, and apple juice to the base, concentrating the fructose load further. Sugar is one of the most consistent pro-inflammatory dietary factors in the Dietary Inflammatory Index. It drives NF-κB activation, the same master switch that the 15 foods above are designed to suppress. 15 foods working to turn that switch off. 60 grams of sugar working to turn it back on. The acai itself fights inflammation. The delivery system surrounding it drives more inflammation than the acai can offset. The superfood ingredient is real. The bowl built around it is pro-inflammatory. Dangerous number 2. Flavored yogurt. Marketed as a probiotic health food. Gut health, immune support, digestive wellness. The probiotic cultures in yogurt are real and beneficial. Lactobacillus and bifidobacterium strains feed the beneficial bacteria in your gut that produce anti-inflammatory short-chain fatty acids. That's genuine science, but a single cup of flavored yogurt contains 20 to 30 grams of added sugar. Some brands pack more sugar per serving than a candy bar. And sugar in the gut feeds pathogenic bacteria, specifically Firmicutes species, that produce pro-inflammatory metabolites. The probiotics in the yogurt feed beneficial bacteria. The sugar in the same cup feeds the harmful bacteria those probiotics are supposed to be competing against. You're funding both sides of a war in your gut, and the sugar is winning.